We're going to move on to 5-5, and the title of this section is Solving Square Root Equations. Our objective is to learn how to solve square root equations, as simple as that. We're actually going to learn how to deal with more than just square root equations, but I'll get into that a little bit later. So a radical equation, or a square root equation, is an equation that has a variable as a radicand. So something that looks like this. Square root of x equals 4. Notice how the variable is inside of the radical symbol, so it's the radicand. So that's just a radical equation. A square root equation specifically has an index of 2. For example, in this case, this would be a square root equation. This is supposed to be an r, by the way, guys. Let's go ahead and take a look at an example of what we can do. You're going to treat this just like you treat any other type of equation. Work by instinct. Do what you know what to do, and you should be fine. For instance, by instinct I mean the following. You already know from equations in Algebra 1 that you want to leave all the variables on one side. And by side I mean, some of you do this little line and you separate two sides using the equal sign. So I want all my constants on the right hand side. Let me call these the right hand side, and this the left hand side. So I want all my constants, all my numbers on the right hand side. So what do? I do a subtraction of 3 because I want to move it. So 8 minus 3 is 5. And I have square root of 2x minus 3. And I'm going to call this step isolate square root, because that's what we did. We left the square root by itself, right? So the next question you have to ask yourself is, how do I get rid of this radicand? How do you get rid of this radical symbol? If it's an index of 2, well, we use what we have learned and we raise it to a power of 2. Notice that, well, I have a 5 now. If I do it to the left hand side, I have to do it to the right hand side as well, so I'm going to square the 5. Next, what do I have left here, guys? I'm going to have, since this exponent cancels out with this index, all I'm going to have left is the 2x minus 3. And we know that 5 squared is 25. Again, we'll repeat a little bit of Algebra 1. We add the 3. And what do I have left? I'm going to have a 2x and a 28. So I'm going to continue over here. Let's see. I'm going to have the 2x equals 28. So we know that that's multiplying, and the way to get rid of a multiplication is a division. So my answer is x equals 14. We're going to continue looking at an example using radical equations. Notice that in this case we don't have a radical, but we have a fraction exponent. And in the previous section we studied that if I have something like this, let's say I have 1/3, I could easily turn this into x to the first power and the 3. Remember, the denominator turns into the index, right? And so this is a 2 over 3. Okay, so we somehow want to solve this equation. Again, we want to get rid of whatever fractional exponent we have, whatever radical we have. There's a couple of ways to do this, but I'm going to show you the faster way to do it. First of all, by instinct, you know that you can get rid of something right away. We know that this 3 is multiplying that binomial, and we know how to get rid of a multiplication, right? Notice that it's not tied to this binomial in any other way other than multiplication. So we know that we can divide by 3 very easily. So if I divide by 3, I'm just going to get a 1 here. The 1 is not necessary, but I'm going to put it there, equals 4. And I'm just going to go ahead and get rid of it. 1 times anything is the same thing. So over here we isolated the fractional exponent, right? Which is the same thing as we did before, isolating the radical. Now, this is, I told you I was going to show you the fastest way possible. Let me tell you what I mean by that. I have a 2 over 3 as an exponent. But ideally, in order to get rid of this, I want to have a 1. Because I want to have something like this. Let me actually skip a couple more lines. I want to have something like this, x plus 1 to the power of 1. That's my ultimate goal. So the question is, how do I turn that 2 over 3 into 1? And the answer is going to be found in Algebra 2. Because if there's something that we can do to this 2 over 3 to turn it into a 1, is multiply it times its reciprocal. And what I mean by reciprocal is the same fraction flipped. Reciprocal of A divided by B is B divided by A. So if I want to turn this 2 over 3 into a 1, I need to multiply it by a 3 over 2, like I showed you over here. So I'm going to have x to the first 2 over 3, but I'm going to raise it to the 3 over 2. And you'll see in a minute what it does. So since I did that to the left hand side, I'm going to do it to the right hand side. I'm going to raise 4 to the 3 over 2. And then what that's going to do is give me x plus 1 to the 6 over 6. And what happens if I turn this into a radical? My index would be 2, and I would have 4 to the third. Right, so 4 to the third is 4 times 4 is 16. Times 4 is 64. So I'm going to erase this and actually put a square root, because this doesn't change, but this inside turns into 4 times 4 times 4, which is 64. Now, this power of 1, I can just get rid of it. I'm going to have x to the 1. Now the square root of 64 is positive or negative 8, right? So that means that I'm going to have two different roots. And why is it positive or negative 8? Because negative 8 times negative 8 negative 8 times negative 8 is 64, and 8 times 8 is also 64. So now I have, similar to what we did when we were doing quadratics, we have two different equations, right? One of them is going to be x plus 1 equals positive 8, and the other one is going to be negative 8. So we're actually going to have two solutions here, 7, and the other one is going to be negative 9. And how can you check this? If you plug this in on the original equation, you'll know that they work just fine.